everybody. Today we're going to talk about vectors, or as Sergey Levin, one of my college professors, would say, vectors. Find our vectors. Now, vectors are very important. They're used in science, physics, math, lots of different places. Now, vectors, as you can see, it's a directed line segment with two parts, and those two parts are magnitude and direction. Okay, and the best way I can think about or show that is we have these line segments with an initial part and an end. And notice we have an arrow to the end part. Okay? Now, just to compare what this means, let's say Mookie Betts is throwing the ball from right field before he got traded to the Dodgers. That could be showing his throw. Now, here's my 6-year-old trying to throw the baseball. Mookie's throwing it much harder, so much more magnitude, and he's throwing it higher to get it all the way home, where my little 6-year-old is doing his best, and he's not even reaching the infield. Okay? And you could have going any which direction, all over the place. Those are all vectors. Okay? In science, you often see that, ooh, that's a terrible job erasing, as forces. And if any of you are taking physics, you might see here's a box sitting on the ground, and then you are pushing the box. And then on the other side, maybe we'll bring in the mountain from Game of Thrones, and he's pushing it. They're pushing against each other. Opposite directions. Who's got the bigger magnitude? The mountain, and you're getting pushed over. All right. So we can put these on a coordinate plane. And I'm going to stay in the first quadrant. And let's say we start here at 1, 2, and we'll go up to 3, 5. We'll call this one PQ. And notice we got the arrow going from P to Q. So therefore, this is P, this is Q. All right? Now, we can compare that to, let's go over one here that starts at 2, 0 and goes to here at 3, 3. And we'll call this AB. So this is vector AB. Okay? Now, we want to talk about magnitude and direction. Let's say we want to see if these are equal. And you can't go by my drawing because it's not good. So, let's break it down. We got to find magnitude. Well, how do we find magnitude? It's distance when it comes to a vector. So we'll use the distance formula. So let's look. PQ goes from 1, 2 to 3, 5. And AB goes from 2, 0 to 3, 3. Now, the first thing, we want to find magnitude, distance formula. Well, how do you find distance formula? Well, maybe you have to look it up, but really, it's going to be x2 minus x1, so 3 minus 1, and then we square it, plus y2 minus y1, 5 minus 2 squared. Okay, so let's see. That's 4 plus 9 square root of that. So we get root 13. That's the magnitude. Let's check the next one. So we're going to go 3 minus 2 squared plus 3 minus 0 squared. Square root the whole thing. That's 1 plus 9 root 10. They're not equal, and it makes sense that they're not. Now, how do I find direction? That's the slope. So we could have also checked that with the slope. Well, how do you find the slope? Seriously, how do you find the slope? y2 minus y1 over x2 minus x1. So we could find, let's just do PQ. Let's find the direction. That's 5 minus 2 over 3 minus 1, 3 halves. There's our direction. Okay, so that just breaks down kind of what a vector is. Let's go on. Squirter, squirter. Now here's the problem. We got vectors floating all over space. Literally. We got satellites out there. We got planets moving. We want to put them all in one place. So what did mathematicians or scientists do? I'm going to put it into standard position. So standard position. That means we're going to start a vector at the origin. Okay, so let's say we have a vector out here doing this, and we have a vector out here doing this. But it'd make a lot more sense to really see it and quantify it if we could move them. We'll call this one PQ again. If we can move it to the origin. Okay, and we can move this one. Again, we'll go with AB. We can move AB to the origin. That's standard position. Makes life a heck of a lot easier. And it's going to help us here when we start talking about component form, because component form will move it. All right, so let's erase it. So let's say we had PQ went from 1, 2 to 5, 8. We want to go to component form. Well, what do? Well, we're going to break down in our vector. I call these vector brackets. Let's find our x's. So x is going to be 5 minus 1. Again, if this is our initial and this is our terminal, because if it went the other way, it wouldn't work. So p, q. So 5 minus 1, and then 8 minus 2. That's dark enough for you to see it. So my vector, and now I can call it a vector, is 4, 6. These just look like greater than or less than symbols. Now, the reason we really like these is because I can quickly find my magnitude. Okay, I don't have to do this squared and this squared and that squared. I can just do this. Square root 4 squared plus 6 squared. So that's 16 plus 36, which is root 52, which I could simplify if needed. And we show magnitude by those, like, almost looks like double absolute values. Okay? Let's try another one. Component form. Smudgy, 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 smudgy. Let's do AB. If A was negative 2, 5, and B was 3, 4. Again, component form. 3 minus a minus 2 is 5. 4 minus a 5 is negative 1. Bam. Component form. All right? That's a short introduction to vectors. In the next lesson, we'll get more in depth in using these. But so far, we saw how we can graph them, how we can find component form, and find magnitude. All right? Any questions, hit me up. And remember,